state briefly with what purpose of Davison and Germer experiment performed and what inference was drawn from this. Okay. The purpose of Davison-Germer experiment was to verify the wave nature of electron. That means the behavior of the electron, how it works. Okay, the nature of the electron, how to verify that one, we are going to use this one. And it confirms the Broglie relations for matter waves or diffraction effect of electron beams from crystal. Okay. Second part, obtain an expression for the ratio of the accelerating potential required to accelerate a proton and an alpha particle to have a small de Broglie wavelength associated with them. Okay, so we need to find here the ratio between the accelerating potentials. For that one, first we need to know here the kinetic energy. Kinetic energy, it is given by P part. Kinetic energy is equal to, we know that, half mv square. So for this one I am going to multiply and divide it by m, that is mass. Then this will becomes mv whole square divided by 2m. Where this is what this is equal to the momentum. Then we can write this one as, momentum can write it as a p square divided by 2m. This is the kinetic energy. And the work done is equal to Q into work done is equal to Q times acceleration potential. That is, acceleration potential is nothing but the V0. Okay. Then this is equal to the kinetic energy. Work done which is equal to kinetic energy. Then we call this as kinetic energy is equal to the work done. Then we can write it as Q into V0 is equal to P square divided by 2m. And P is equal to under root of 2m Q into V0. Okay. Now by applying the de Broglie wavelength formula, that is lambda is equal to h divided by p, where p value we substitute this one, then lambda is equal to h divided by under root of 2m q times V0. And we know that the wavelength of the alpha particle is equal to the wavelength of the proton. That is alpha lambda p is equal to the lambda alpha. Then substitute these values. We will get here h divided by under root of 2m proton V not proton into q proton is equal to h divided by under root of 2m alpha V naught alpha into p alpha. Then we cancel this h and squaring on both sides, we will get 2mp q times qp into V0 proton is equal to 2m alpha q alpha V0 alpha. If you are going to cancel these two on both sides, then we will get the ratio of V0 proton divided by V0 alpha is equal to m alpha into q alpha divided by mp into qp. And the mass of the alpha particle is equal to 4 times of the proton, and the charge the charge of alpha particle is equal to 2 times of proton. By this one, we can say that V naught proton divided by V naught alpha is equal to the mass of alpha particle is equal to 4 times of mass of proton, means this becomes 4 by 1 into the charge of alpha particle is equal to 2 times of proton. This becomes 2 by 1. Then we can write this one as 8 by 1. So this is the ratio of accelerating potential. An electron and a proton are accelerated through the same potential. Which one of these two has? First one, greater value of de Broglie wavelength associated with it, and second one, lesser momentum. As we know from the previous video, that is lambda is equal to h divided by under root of 2 times n, q and v naught, right? This indicates that the lambda is inversely proportional to the mass under root of the mass of the element. Then we can say here that the mass of the proton is greater than the mass of the electron. Therefore, the lambda of electron is greater than the lambda of proton. Similarly, the momentum also. That is the second question. Momentum is the lambda of electron is greater than the lambda of the proton. Lambda of electron is greater than the lambda of proton. Hence, therefore, the momentum of electron is lesser. Momentum of electron is lesser. Here, this justifying, okay. That part B here, the part B, okay. How is the momentum of a particle related with its de Broglie wavelength? Show the variation on the graph. We know that lambda is equal to the h divided by p, and the graph is looks like this. There is a I divided by p, where the p value is increases, the I value is gradually decreases. This is the variation of the graph.